Data is everywhere, flowing in real time, scaling up in storage, and powering everything from business insights to machine learning models. But managing all that data, that's where the right tools comes in. Some of the most powerful tools out there are open source. A very big thanks to the Apache Software Foundation. Today we are exploring Apache frameworks for data engineering. If you are new to Apache, think of it as an open source treasure chest. Each tool is designed to help engineers to tackle different parts of data journey, from data collection all the way to analyzing it and making sense of it. So why Apache? Well, besides being free and open source, Apache frameworks are incredibly powerful and scalable. They are developed and supported by a global community, which means constant innovation and real-world solutions. Plus, you'll find them used in everything from startups to some of the biggest tech companies out there. Let's break it down. Apache covers every step of data engineering. If you need to collect data, there is Kafka and there's Flume. For real-time processing, tools like Spark and Flink have you covered. And managing workflows, then you don't need to look any further than Apache Airflow. Whatever the task is, there's an Apache project built to handle it. In this video, we are going to be taking a closer look at different projects that are being built by Apache Software Foundation and how some of them are applicable to data engineering. So let's get into that and get started. These are the list of data engineering projects that are sponsored by Apache Software Foundation as an open source tool. For data ingestion, we have Apache Kafka, Apache Flume, Naifa, and Scoop. These four are majorly based on data ingestion. They help you to ingest data, whether it's real-time or batch. While for data storage, we have Apache Hadoop HDFS, Cassandra, HBase, and Hive. For data processing, we have Apache Spark, Flink, Beam, and Storm. Also, for data orchestration and workflow, we have Apache Airflow and Woozy. Data querying and analytics, Apache Druid, Kylin, Druid, and Impala. While for data serialization and schema management, we have Apache Avro, Parquet, and Arrow. And finally, for machine learning and data science, we have Mahout, which is a scalable library that is focused on clustering, classification, and recommendation. We also have MXNet, a retired project that is a deep learning project that focuses majorly on scaling for distributed training and deployment. And finally, Apache Spark MLlib. This is a machine learning library in Apache Spark for scalable machine learning algorithms. So let's get into the architecture of the system we are going to be building today and see what that looks like. So let's take a look at a super high level view of what the system looks like. So under the hood, or on top of the hood, we are going to have e-commerce store, which is going to be sending data via Python, but you can also use any other programming language or any other approach that you prefer. This can be applied to any, just picking a use case could be applied to any use case of your choice. So you have an e-commerce store that is going to be sending data into Apache Kafka. And with Apache Kafka, once the data gets in there, we have Apache Druid that is listening into the data that is coming into Apache Kafka. What that means is, once the data gets into Druid, you can decide to write your query and aggregation in Apache Druid, or you can further to push it to Apache Superset for visualization on the dashboard. Whatever works for you, but you can do most of the aggregation and tooling and stuff like that on Apache Druid. So that's on the top of the hood. So now let's pop the bonnet and look into what's inside the hood itself. Down into the architecture, doing a deeper dive into each of the architectures and components, we have the e-commerce superstore. I don't think we can go deeper into this. Maybe unless you want to do the design the data and the data modeling of this. But yeah, there is no need for that. We have something that is sending data with Python from our e-commerce store into Apache Kafka. And we all know the new improvement in Apache Kafka is you no longer have a dependency on Zookeeper. Before now, Zookeeper becomes the major bottleneck where any of the brokers that is listening on the Zookeeper, once Zookeeper goes down, the entire cluster goes off. So what you do, of course, you need to have multiple clusters and all that. But what the new improvement looks like is the K-Raft mode, where you have the controllers and the broker. The controllers and the brokers. Okay, the controllers are in charge of doing the distribution and managing, just like you have Zookeeper, but in this case you now have multiple controllers, and each of the brokers as well can also serve as controllers if you prefer. So you could have, if you have 5 clusters, you could make all of them both broker and controller at the same time, but that's still not the best architecture. Usually you want to have maybe two or three controllers, and then you have a spread out of your brokers where each of them can be managed by these controllers. So if the controller goes down, the dormant ones will always pick up once that goes down. So that's why everything is going to be in a quorum. The leader will be elected once you spin up your services, and once the leader goes down, those ones will re-elect another leader again and pick up from where the previous leader stopped. But yeah, that's a little bit down the rabbit hole of Apache Kafka. You can check the documentation up if you are interested in what each of these means and how it works. But once the data gets in there, we stream the data into Apache Druid. Now we are popping up the hood of Apache Druid itself, and these are some of the components we'll be implementing in this video for Apache Druid. We have the router, the middle manager, the historical, the overload, the coordinator, and the broker. Now the coordinator itself, if we want to put like a definition to it, what it does is to manage the data availability in the cluster. Once the data comes in, the coordinator makes sure that the data is available to all of the services across board, while the overload helps with the data ingestion workloads to make sure that each of whoever needs to get assigned to this data that is coming in, we need to assign it to whoever that needs to do that. The overload takes care of that. The broker is going to be handling the querying and from the client. Okay, so if somebody sends in a query, it goes to the broker, and the broker helps to do whatever needs to be done via the querying. The router, of course, is going to be the one sending data from the broker to the coordinator to the overload, even the middle manager and the historical. But this guy is the one that is going to be routing requests among each of these independent services. Well, they're kind of interdependent, not really independent, to be honest. Zookeeper itself is the one controlling and orchestrating everything that goes on in the cluster. But that means if Zookeeper goes down, of course, the cluster is off. So, but yeah, Zookeeper stands in the center of everything, and it orchestrates everything, just like you had on Kafka before. But Zookeeper is at the center of all these things. So the historical in our case is going to be the one that helps us with, to store our query data. So if you're writing queries, doing aggregations, the historical is your point of contact in there. And the middle manager is majorly used for data ingestion. So once data comes, whether it's a batch data or stream data, the middle manager is the one that helps to do the data ingestion, and also it's also communicates with the rest of the platform and the modules in the cluster. Okay, eventually, once all of this is done, the data gets forwarded to Apache Superset through some connectors that is going to be implemented. Well, it's already implemented. You just need to connect to Apache Druid, and you can visualize your data in real time on Superset's dashboard. Now, you don't have to necessarily use Apache Superset if you're not familiar with it. If you're comfortable with Tableau, you can use that. Power BI doesn't support Apache Druid yet, or probably there's a connector that can be used in the interim, but officially there is no direct support for Apache Druid. But yeah, Tableau supports it. You can use something like Apply Pivot if you prefer. I think a Redash as well can be used for the visualization, maybe Plotly, maybe Streamlit as well. But yeah, a couple of the other tools can also be used in place of Apache Superset. And if you prefer to use them concurrently, all well and good. So that's your computer that is talking. Yeah, but it doesn't really matter. What matters is you get your data into some visualization dashboard for visualization. Now, let's get into the architecture of the system. And well, we've just discussed the architecture. Now let's get into the coding. After discussing this architecture, we go into the coding and get started. Now, before I go into the coding, if this is your first time of being into this channel and you've not subscribed, please don't forget to click the subscribe button, like, comment, and share these videos to your colleagues and friends. Even send it to your timeline and tag me. I'll be more than happy to repost and like them and even comment on each of them. And of course, don't forget to leave feedback in the comment section. I'll be more than happy to engage in intellectual discussions. And if you have comments or you get stuck, please don't hesitate to reach out to ask me. With that said, let's get into the coding section and get started. I'm going to start by creating a new project, and we can get started with the project. So as usual, what you want to do basically is I'm going to PyCharm. Most likely, if this is not your first time or you've been watching my videos before, I prefer to use PyCharm for some reason which is sentimental. You can decide to use VS Code, but yeah, my preference is PyCharm. So if you decide to use PyCharm, all well and good. If not, you can use any other IDE that you prefer, or you can use Notepad if you like, or Vim if you prefer that. Okay, so I'm just going to Apache DE. I'll just call it Apache Data Engineering. Yeah, that's a good name. I'm really bad at naming something, so if you prefer to create a welcome script, you can decide to do that. But I'll be using Python version of 3.10. Please, this is very important. If you're using the latest version 3.13, you may run into some issues, and that might lead to some connecting issues, or just a chain reaction, to be honest. But yeah, I think 3.10 is fairly stable. It's really stable. I wouldn't say fairly stable. So you can decide to use Python 3.10. So yeah, I'm creating a project with Python 3.10 with PyCharm. So I'll create a project. Okay, so yeah, our project is created. So the first thing we want to do is increase the font size so everybody is able to see it and it's legible enough. I hope this is okay. Okay, this should be fine. Now the next thing you want to do is go into the terminal and ensure that your Python is in the right directory. So if you say which Python, it should be in the venv that is created by PyCharm. So if not, or you use a different IDE, you might want to create a virtual environment that you'll be using in your own case. Yeah, well, either way, yeah, you get the point. Okay, so once that is done, you can do python main.py to make sure that you are able to run this. So if this works just fine and you don't have any issues, then you're good to go. You can continue on to the next step. So the next step is now to start getting the architectures in place. We're going to be using Docker, of course. So we need to get in our Docker compose.yaml. So in our Docker compose, we need to get in our services. So the first service that we're going to be bringing into the picture is going to be, drum roll, let's look at it, Apache Kafka. Okay, so let's get in there. So we're going to start with the controllers, then we bring in the brokers, and then we try and connect each of them together. So I already have this in my notes, so I'm just going to pull up my notes and paste them in here. So if you need the code or you want to use the same code, you can get that via the description in the underneath this video. So our Kafka controller is going to be using Python 3.81, and the process role is going to be called the controller. We're going to be having two controllers. You can increase this to 3 if you prefer, but I'll be using 2 controllers, and the rebalancing milliseconds is going to be 0, and the listener name is going to be 0. So the listener name as well in here for the controller is going to be controller, and for interbroker is going to be plain text, so for exchanging information between the controllers. So that's what's going to be used, and the Kafka node ID is going to be 1. So literally you can copy paste this and you have the second controller as well. So I've done that already, so I'll just copy that and paste it here. Okay, so I have my second Kafka controller here. The same thing, the only thing that is changing is the node ID, which is 2. It's literally a copy paste of that. Now let's get in our broker. This is where things get a little bit more interesting. So for our broker, we get in the image, which is Kafka 3.81, not the latest, but yeah, it's very close to the latest one. The container name is going to be Kafka broker. We are exposing 2902 as our external port, and that's going to be mapping to 9092 on the internal of the container. So the node ID is going to be 3. The process role in this case is going to be broker. If you can still recall, this is controller. The previous 2 were controllers. Now this is our broker. Okay, so we have the plain text and we have our broker, which is the broker IP, the host and the port that will be used for the communication, both internally and externally. So we're using, for the external communication, we're using localhost. For the internal communication, is going to be Kafka broker. Please, this is very important, don't forget. Yeah, the same thing is similar here. We're going to be having our quorum voters as there. And the same thing, we need to do the same for the next broker, which is our second broker in this case. So we have 2 controllers and 2 brokers. Okay, so this is node ID 4, similar thing, except the port. We're exposing this in the 39092, but literally the same thing is going to be applicable with the Kafka broker as well. So we have the dependency, which is going to be the controller. So the controllers needs to be in place before the Kafka brokers are in place. Now with that said, I think we can just get started with this, and once we get to the other bit of Apache Druid, we can check those out. Okay, so yeah, that should be fine, and yeah, we can check this out and take this for a spin. So okay, cool. So we just need to do docker compose up detached, and this is going to start our services. So we are using Apache DE_code with you as the network. So because I already have the image on my local system, so it's not going to be pulling that again, but just in case you don't have that, you might have to pull all the images down to your local system. And this is what the Orbstack dashboard look like. So we have Apache DE, and this is our brokers and controllers. So for some reason this particular broker is down and it says illegal instruction ID. So let's see and fix that. So in our Kafka broker, the node ID is this, and the second one is this. So I'm just going to docker compose down. Just delete everything, yeah, and then start up. So this is what you see once you start everything up. All the images are off your system, and this is your first time of pulling all the images down to your local system. So you just pull all of this, and it takes a few seconds for that to be started. Now let's see what that look like. If you look at the controllers, we have 2 controllers, 2 brokers. So let's see what's going on in each of them. The Kafka is started, good. And in our Kafka broker 1, Kafka is also started. So that means there's a connection between our 2 controllers in KRaft mode, and this is good. Our registration has been persisted to the metadata log, which is cool. So that means our configuration is working just fine, and the controller is acknowledged. So this guy is the leader, I believe, and the configuration of this guy, this is the second guy. Whichever one is the leader. So yeah, that's okay. Unless we want to look into the code, we may not be able to see the leader directly. Good. Okay then, now our controller is done, the broker is done, so the KRaft mode is literally done. So the second bit is to get in our Apache Druid into the picture. How do we do that? So we need to start by pulling each of these guys into the picture. Now because Zookeeper is going to be at the center of everything, it only makes sense to start with the Zookeeper in that case. By the way, so to get in the Zookeeper, I'll just copy the code for Zookeeper into the picture. So Zookeeper comes in here. I'm just going to pull this as Apache Druid. So our Zookeeper is going to be Zookeeper 3.9. I think 3.5 is the minimum supported version for Apache Druid. So if you're using lesser version, you might run into issues. So I'll say you should try and use maybe 3.5 and above. You should be okay. Then the port is 2181 as usual. Then the Zookeeper ID is going to be 1, just to put the else check in place, because once there's a dependency in Docker, you need to put whoever is going to be at the root with an else check, so everybody can be sure that this particular person I'm dependent on, this service I'm dependent on, this is how to check that it's ready to accept connection. So the Zookeeper else check is this. Good. Now the next bit is to pull in coordinator. So let's pull in the coordinator. So the coordinator is going to be like this. So the coordinator is using the Druid 3100. The container name is coordinator. The volume is Druid shared Druid coordinator var, which we don't have right now. So let's pull those in to make things make sense. So we're going to have a volume that will be used here. I'll prefer the volumes to be at the top. So we have the metadata, the middle manager, which is this guy. That's the volume. We have the historical, the broker, the coordinator, the router, and the Druid shared. So yeah, so that's the volume for the Druid shared and the coordinator. So each of them we have one Druid share and one volume that is going to be linked to each of them. Okay, so once the coordinator comes into the picture, the dependency is going to be on Zookeeper and Postgres. We need to bring in Postgres as well because we don't have one right now. So there's a dependency on Postgres, so I'm just going to copy paste Postgres just above the Zookeeper, above the coordinator here and below Zookeeper. So if you prefer to use the volume here, it's okay. Just uncomment that bit. So the container name is Postgres. I'm using Postgres 16.0. The port is 5432. The volume is the metadata that we just created, and then we have the environment, which is the password, the super strong password, and the username and password is going to, and the DB name is going to be Apache Druid. So you can check all of the configurations up on Postgres once it is set up and everything is working. Yeah, so the dependency is sorted. The port is 8081. The command for this coordinate is the coordinator, and we have the env file. I'm going to put this as the last thing that we need to do because it's a little bit more advanced, and we need to talk a little bit about each of them. Okay, so the coordinator, just remind me, maybe not. We have an environment that needs to go into the picture before we start up the services. Okay then, so our coordinator is in place. Let's bring in our Druid broker. So I call it broker, but you can change the name if you prefer. Just make sure that anywhere that this broker is referenced is changed to whatever the new name is. Okay, so the only thing that is changing here majorly is the broker command. We have the volume of broker var, and yeah, we need to bring the rest in as well. So we've taken care of the coordinator, taking care of the broker. We need to bring 4 additional things into the picture. So we have the historical. Historical is here, and this is the guy. It's going to be Druid shared. I think there should be a Druid share for our broker as well, so should be fine here. Yeah, we have the Zookeeper and the rest. Then the command for this guy is historical, and we still need the env file, which is going to be shared by everybody on the cluster. We have the middle manager as well, so let's bring that in. Middle manager is going to be here. The command is going to be a little bit different as well. It's going to be middle manager, just like that. The only major thing that is changing is historical, middle manager, coordinator, and the rest. So the final one is router. So let's bring it in, the router. So the router is this guy, and we have the command for the router, and we have the env file that needs to also come in as well. So yeah, I believe that sorts it out. So technically we have the router, the middle manager, historical, overload, coordinator, and the broker. Okay, so yeah, and that's it. But one thing that is missing majorly is the overload. Overload is implied, but yeah, so let's see if this doesn't work. We might need to have a separate service for overload, but it's usually implied, so you don't necessarily have to spin up a separate overload. But in some cases, if you don't have that in place, you might have a separate service for overload. So let's bring that in. So the final thing that we need to do is the environment. So let's touch in the environment. It's called environment, so let's touch that. So I'm going to just copy paste the environment. It's a lot, so I'm just going to maybe talk through them. So this if you want to increase the resource allocation, you need to get the maximum size and the minimum size, but right now it's just commented out. But if you need to have a specific configurations for Apache Druid in terms of the JVM size and memory allocations, so you can increase this maybe, or comment this bit, and you should be good to go. So we have a single node configuration, which is the micro quick start. Technically it's not a micro quick start, but yeah, you get the point. You can increase the memory size if you prefer, but yeah. So this is the extension. These are the list of extensions that is out of the box, but I added this last bit for Druid Kafka indexing services, so it's able to connect to Apache Kafka. The host is going to be the Zookeeper, and the metadata storage, where the data is going to be stored, is going to be Postgres. So we're using Postgres as this 5432. The username and password is going to be super strong password, of course. The user ID is Druid, and the connector password is foolish password. And if you prefer, you can change this to maybe something like super strong password. Okay. Then of course the Java options is going to be the maximum is 1 gig, the minimum is 1 gig, the maximum direct memory size. I don't need to read all of this. If you just go through the environment, you should be good to go. Yeah, literally everything is as it is. So yeah, we can just spin this up. I'm just going to drop all of this code in the comment in the description, so you can always have access to each of them. So now we're going to have these services being pulled from Docker Hub, and we can spin all of this up as required. Now while this is going on in the background, so let's go back to our main.py and start pulling in the producer, which is this guy, the one that is going to be sending the e-commerce store. I'm going to try as much as possible to keep it super simple, but you can always build on this and make it a little bit more elaborate. By the way, for production ready systems, you need to add additional things like the observability and monitoring, and whatever additional peripherals that you want to do to this for this to make more sense. And we're using the micro quick start, so you may not want to use the micro quick start for a production system, so you might want to use the production ready configurations in there, just fine-tuning that, but it's just going to be majorly touches here and there. Now for the main.py, let's get in some of the coding. So I'm going to be using JSON. So yeah, the major thing that I'll be using is Faker, because that's used to generate data from random sources. So we have Faker and then Kafka Python, which is used to connect to Apache Kafka from Python. Okay, so yeah, once that is installed, I have this and we're good to go. Our environment is already activated, so we're good. And the next thing is to now start with the simpler version of this. So I'm not going to be super production ready in this code. It's just to like generate the data and push it to Kafka. That's simple as it is. So I'm going to have from Faker import Faker, and then from my Kafka import Kafka producer. So I just need to have, if the name is going to be main, I need to get Faker into the picture, and I need to have a function called generate data. And the generate data is going to have a data object, which is going to be a JSON object, and each of these is now going to be the one to pull the data into the data that will be returned. So I've just returned data here, and I just need to bring in random from random import random. Okay, now for our data, so I'm just going to have user ID, that's going to be random.get round bits. I just give it 32 integer. You can change it to whatever you like, but yeah. And I have my data here. It's going to be event type. So majorly this is event system for e-commerce system. So I'm going to have random.choice, and that's going to be a choice of click, view, or purchase. Okay, so you can increase that. And in real system, you want to connect this to a live system that provides this data and into Kafka. So we have the country of origin is going to be faker.country. Yeah, that should be fine. If I'll just make it country code, that will be faker equals to faker. Yeah, that should be okay. Then the city is going to be city. Yeah, we have the device ID. Device ID is going to be random, maybe not device ID, device random dot let's use choice. It's going to be pick any of this, maybe mobile, if I can only type mobile, desktop, and we have tablet. Then the product ID is going to be random dot get round bits of 32 as well. Could be anything at all, so we're just getting something in there. Price is going to be round of random dot uniform between 5 and 500, and round it to 2 decimal places. Then we have the quantity, just random integer between 1 and 100, and the data timestamp is going to be round time. So just bring in the time from date time. I prefer it from time. Yeah, so yeah, that's taken care of, and the data is done. I'm going to just return data. I already did, didn't I? So yeah, I return the data here, and that should be okay. Okay, then that looks much better, isn't it? I'm just adjusting this a little bit. Good. All right, so the next thing is to get in our the country that we want to use. So let's use the in US. So we have English local, and yeah, so that's it. So the data is generated now. The next thing we want to do is getting our topic, as well as where we are producing into, which is the producer. So our topic name is going to be, let's call it e-commerce data, and our producer is going to be Kafka producer. And we just need to get in our bootstrap servers. We're going to come back to this shortly, but we have the value serializer. It's going to be lambda json.dumps. We encode this into UTF-8. But our bootstrap servers is going to be, our bootstrap server is going to be localhost 9092. Let's see that. Our bootstrap server is going to be coming from Kafka broker 1092, and this is 29092 for our Kafka broker 1 and 3092. So yeah, so that should be localhost 3092, I believe. Yeah, so that's our brokers that we're sending data into, and we have our producer object. So the next thing is just to have a while object, which is going to send the data depending on how much data we want to send. So let's start with 0. Then while count is less than 10, count plus equals to 1. Okay, just increase count, and then we just generated the data. So we just call this, yeah, we can call this rec. It's going to be, yeah, generate data. So once we generate the data, the next thing we want to do is send it to a particular topic. So we just say producer dot send into the topic name, and the value is going to be rec, and that's it really. Just to the next is just to like print that the record is sent. So we just we sent the record count. Yeah, that's it. You can just producer.flush to make sure that the data gets sent across. Okay, so if you prefer to sleep in the middle, you can do that, but there's no need for that really. It's just to check that we are able to send at least 10 data for now into our Kafka. So let's see what that looks like. So I'm just going to Python main.py. Yeah, so the data is here. We have 10 records, and let's check our well, maybe not dashboard. So I have my big data tools with PyCharm, so I can use that. If you prefer to use something like a UI, maybe something like Confluent Control Center, you can use that. A couple of other tools, about 32 of them or thereabout. You can, a lot of UI for visualization, and one of them is just this client. Or if you prefer, you can use the terminal if that's what you like. To just go through this, I'll just delete this connection, and for my message broker, I'll just select Kafka from there, and my broker is going to be localhost, so I'll change this to localhost. For some reason, sometimes 127.0.0.1, the localhost IP address, sometimes do not work. So, but most times it works, but there's no need to experiment at this stage. So we have 29092 and 39092 as our bootstrap servers. So if you have some security on the cluster, Kafka clusters, you could use that as well. But yeah, we just leave it at that. We're able to connect to that, and then we connect. So just below this, we just sent 10 records. If you check the terminal, we have 10 records in here that are just sent to Kafka. And if you check this, you're able to see that we have 10 records in our Kafka, but we are not able to see it. So we need to have some sort of consumer group, and if you want to produce data, you can do that, but we don't need that here. You have consumer group that you just need to create. So it's going to be consuming data from this particular topic. The key is going to be a string. Most times it's usually a string, and the value is going to be JSON or any other format, maybe Avro, Protobuf, and the rest. But yeah, I'll just leave it as JSON for now. We are going to be starting from where, not the latest, because the latest is going to be going forward, but we want to start from the beginning. So yeah, so that will be from the beginning. The limit is if the chunk of data you want to pick from there, and if you have a filter, you can apply your filter here. I don't need anything else. I just start consuming this data, and you can see the data that now it looks like. So we have this data. If each of this, you can view the value and the details of individual records in here, and that's what it looks like. So we have 10 records right now. We can start with this and connect Apache Druid to this particular guy, and we can start consuming data from here, at least for these 10 records for now. We can always improve and produce data much later. So now going back to this guy, yeah, so going back to, where is it, Orbstack dashboard, we have our router. So I'll just go through the router, and that will be localhost port 8888. Yeah, and that's our UI and how it looks like. So right now we have one router, one broker, one historical and middle manager. Let's see what each of the details looks like. It says there was an error getting worker info. We can ignore this for now, but yeah. So we have router, broker, historical, middle manager. I think we could also get in one more guy into this picture, which is the overlord, I believe. But for now, let's see what that look like. Okay, so now let's see, is something missing here? The coordinator is here. Is it connected? It's not. It says unknown exception Postgres, so it's not able to connect to Postgres, is it? Postgres is here for so what I'm going to do is stop our coordinator and start it again. If that doesn't resolve it, I'll just drop it and recreate it. It says unknown host. So let's go back to our environment. In our environment, we have our host here as we have Postgres. Let's see, our host is going to be Postgres, and the Druid username and the password is going to be super strong password. I don't know how I missed these bits. Yeah, and then we can just go back here, docker compose down. Now this error that I'm seeing, if you just remove all of the services, and yeah, I just need to make sure that my host is Postgres and the password is fine. And in my docker compose, I need to make sure that everything is on the same network. I think I mentioned that before, so I'm just going to copy this network, and I think Postgres is probably not on the same network. Yeah, so I'm just going to paste that in here and we should be fine. So what I'm going to do is send this up again for processing and see if that works and fix whatever error that we're having with the coordinator itself. So let's go back here and monitor what the coordinator is saying. So now it usually fails here, but now it's, yeah, good, it's working now. Cool. So the coordinator is up and running, and let's check. Apparently the rest should be fine. So I'm just going to go back to Druid and see if everything is working. Good. So we have one overload. You know, I mentioned that overload is usually implied. So we have the coordinator, the router, the broker, the historical, and the middle manager. But the overload, we didn't specify that, but it's usually implied. So you can have it on the same cluster as well. So the coordinator and the overload usually sits at the same time, but if you have a separate cluster, you can create a separate overload that connects to the coordinator as well. But yeah, we leave it at that. So this is the leader, the rest can just be the follower. Yeah, going back here, we have the status. So we now have a couple of services that have been loaded for us in the system. And if you look at this, we have the AWS, come on, and just scroll down here, we have the Druid indexing service. This is very important for us to be able to connect to Apache Kafka. But in some cases, if you require some additional data sources that is not supported out of the box, you need to just install the service and enable the indexing service or whatever the query service is, so the system can recognize that data point and you can start loading data from there. I'll show you a simple trick for that. So when you are loading data, it's going to ask you whether you are loading a streaming data or batch SQL, which is a multi-stage query, or the batch classic. The difference is the batch classic is usually where you upload files into the system. You know, upload your CSV file and you can do whatever aggregations you want with it. But the batch SQL is usually you have some SQL scripts that you want to use for the multi-staging. While the streaming is something like Apache Kafka that we've been working with ever since for the execution. So you can connect to Kafka, to Red Panda, or to whatever from there. They usually use the same protocol. I mean, Red Panda and Kafka, Red Panda usually connects to, I don't want to go to the rabbit hole, but the same protocol that Kafka uses is what Red Panda is using, but the architecture is separately different. Okay, so going into the streaming, we have the streaming new spec, or you continue from the previous stream. So I'll just create a new one. And here we have Apache Kafka, which is enabled by default because we enabled the indexing service. We have Amazon Kinesis, which is not enabled. So if you want to do that, go back to the environment variable in the list of services. You need to add Amazon Kinesis in there. Azure Event Hub is supported by default, and you have other services that you need to submit something into the supervisor, or you submit a task for that. But that's out of the scope for this video. So Apache Kafka is working fine, so we just need to connect the data. But before we do that, just hold on. We have our data sources, where the list of data sources that we're connecting to is going to be seated in. So something like Apache Kafka, once we load the data source and connect to that, it's going to come into this data source. The supervisor is the one that is managing everything that is going on, where you can visualize it. You know, I mentioned to you earlier that some of the services are usually connected, but this supervisor is where you see the status of the task and the stream. For in our case, the streaming service that is coming in from Apache Kafka is going to be sitting in this particular block. We have the task, which is the executions that goes in there, which service, which data source is going to be applicable to. Then the segment is the data that you are loading. Usually is batched up. So if you send a data at 6 o'clock, it's going to be in the same segment. If you send another one and there's a break, for example, and they send another one at 6:30, and they are in the between 6 and 6:30, there are no additional record, maybe just once in every 30 minutes. Each of them will be batched in the same segment. So, and they will be partitioned as required. Then we have the services, which are the list of services that are there. You have the lookup and you have the explorer. Yeah, that's it. Then you have the settings, of course, if you want to have some changes made to that. You have the Druid doctor. This is the guy that helps you to keep check. This is connected to usually Zookeeper, so it keeps track of all the services and tells you once there's an issue in any of those particular services. But yeah, enough of the theory. If you prefer to go through that the rabbit hole of the theory, please go through the documentation of Apache Druid. You have enough information on there. Now let's start loading data. Apache Kafka, we connect to that. What's our host information? Can anybody remind me? Yeah, so that will be the Kafka broker 29092 and then Kafka broker 1 39092. Good. Now, what topic are we consuming data from? If you can still recall, kudos. E-commerce data, I believe. Let's apply this and see if we're able to connect to that. Please connect. Please connect. Please connect. Usually doesn't take this long, but I don't know why. Did I mess something up? What's the topic name? Let's see. E-commerce underscore data. Yeah. And the Kafka broker 29092, Kafka broker 39092. Let me just be sure. Kafka broker 1. Yeah. Something is wrong here. Is 10920, yeah, and Kafka broker, so that's wrong. So I'm just going to change this to 10902 and this and apply. That should reset it, shouldn't it? I'm just going to refresh this page. Okay, start a new streaming, Kafka connect, yeah, and e-commerce data, apply. No data returned from the sampler. That's strange. We have data in e-commerce data. I just need to be sure. I'm just going to copy this. For some reason, I think it's a comma, not a semicolon. Yeah. Yeah, it's a comma. I was putting a semicolon in there for some reasons. I don't know. Kafka broker 1. Let's see. Okay, so it looks like it's connected, but there's no data. What does that mean? Let's see. Do we have data in Kafka? Let's see. Where's our consumer? Do we still have data in there? Ah, yeah. I think I shut it down. Ah, yeah, that's why. I was surprised. So it actually connected the other time. Yeah. So 10 records are there now, and I should have new data coming into the topic. Just go into Kafka again and do a refresh. Yeah, there's data here. Yeah, I can check again. Yeah, so the data is here. So yeah, we should be good now. And I just need to apply this again. Cool. So the data is coming in from Kafka. So we have the data right now. And so the next thing is to pass it. So these are the stages that we need to go through. The starting, the connection, the passing of the data, passing the time, the transformation. If there's any filtering that needs to be applied, you do the application here. And then you configure your schema, the partitioning, the tuning, the publishing, and you can edit the specs if you need to have additional specs in here, but it's okay. Yeah, let's see what that look like. So I'll just pass the data. So it's going to put it in tabular format as the data is coming through. And this can be done for unstructured data as well. It doesn't necessarily have to be structured. Okay, cool. So this makes sense. So we have the event type, the country, the city, the device, the product ID, the price, the quantity, and then the timestamp. So what happens is, once the data is understood and we have the data in the system, the concept of dimension, excuse me, the concept of dimensions and metrics comes into the picture. There are some data that will be treated as dimension, which are the categorical data. Then there are some that will be treated as metrics, something like quantity, the price, they will be treated as metrics. And you can, perform some aggregation based on those. And of course the dimension as well. Yeah, we just leave this as it is. But in case you need to, let's say you need to perform some transformation based on this, you can actually write your in the transformation. We'll get there shortly. We pass the time. This is the time the data is coming in. This is from Kafka majorly, and this is from timestamp. So if you see the timestamp here, so that's converted into time based on understanding of the data. So once that is done, this is the time the data comes in, which is transformed from the timestamp. And then we have, if there's any missing value, you can address that with the default value in here. So yeah, so in the transformation, this is where you write your transformation code. For our use case, let's say you have a full name. You can separate the full name into first name or last name, or if you have for some reason you have first name and last name and you want to have full name, you can do that. But let me show you a simple trick on how you can work with that. So let's say I want to concatenate the country as well as the city as a transformation. I can call this country underscore city, and this is going to be an expression. So I just need to pick in the column name, so that will be the country, and I need to add a plus here, and then I put in the city and I apply. So that is going to create a new column called country underscore city in here. So you can see that the KN Rogersville is there. So based on that, you have the country and the city. But in our case, price and quantity, we can use that to get the final price, or the value, which is the price, or the total sales, which is the price multiplied by quantity. So we can have that, which is the, let's say, total sales. We can have price, which is price multiplied by quantity. quantity as our total sales, and this is going to be the multiplication of both of that. You can see if you multiply this by this, you get that, and that's good. So yeah, we leave it at that for now, but those are the two transformation that I want to do here. You don't have to do any other thing, to be honest. We can leave it at that. Then next is filter. So here in the filter, you can remove unwanted columns. So let's say there are some list of unwanted columns that need to be removed, or some null columns that you want to filter out. You can do that here. So next we're going to configure schema. So this is where we configure the dimensions and the metrics. So for the blue ones, they are the metrics, and the green ones are the dimensions. If you look at this, we have the long and the string. So usually the strings are classified as categorical variables. So yeah, we need to change some of this, the data type. So the data type of the city is going to be float. No, sorry, it's still string. I selected the wrong thing. So sales is going to be float, and apply. So if you see that when I apply the float to that, it changed it from dimension to categorical value. And then yeah, the rest can be categorical, which are the dimension, of course. And I need to change this as well to float. Yeah, well, double is fine as well, so it's okay. So that's yeah, I think that's fine. We've been able to identify the strings as the dimensions and the blues as the metrics, which is fine. I think we can continue with that. Then the partitioning. Now the segment granularity we're talking about here is going to be the partitioning by the time. So if you are getting data every 30 minutes, it only makes sense to partition it by the hour or something like that. If you are getting it every hour, you partition it by the hour. If you want to partition all the data by day, you can also do that. So if you just drop this down, you have the hour, day, month, year, or. So in our case, I'll just partition this by hour, but I believe you can still reduce the segment granularity much later if you prefer. Maybe something to minutes. But yeah, I will leave it at that for now. Then I have the tuning. The tuning is the input tuning. So the duration, the task count, and stuff like that. So these are like additional configurations that you need to do. So once you do this, this is going to be applied to the data that is coming in. So in our case, I'm going to be using the earliest offset, which is the first record that gets into the topic. So I'm going to change this to true, and we should be fine. The rest I'll leave it as default. Then the publish configuration. So the data source that will be inside here is going to be called e-commerce data. Is suspended is false because we want to start it automatically once it starts. The parser error reporting is okay. I'll leave it at that, and then I can edit the specs. So now, if at the end of the day maybe you have a copy of these specs, you don't necessarily have to go in through individual stages and start putting data in there. You can actually copy paste your spec in here and adjust. So I think I will leave it as it is, but just in case you want to have a separate configuration, you can do that. Now yeah, I can leave it at that. So the segment granularity is hourly, the roll-up is false, and the query granularity is that. That's okay. And then I'll just submit this to the supervisor for running. So yeah, the data is submitted to the supervisor, and you can see in the supervisor level is currently pending. If you refresh a couple times, it could be able to change to running once it's the configurations are valid and all that. But if there's an error, you should see it here as well. So if you want to view what the properties is, if you click on the e-commerce data, you should be able to see the data and some of the specs that you apply to the data that is coming in. Good. Now if you go back to the data source, you see that we have one data here, which is the data that is pulled from Kafka. We have one segment here right now, and this is the segment data. So these are the records that are coming in from Kafka automatically, and so by the time we have a new set of data, it's going to be appended to this, but in a separate segment. Okay. Yeah, so that's it really. So let's go into the query window and see if we can write some queries on this. So I can select all of the columns here and run. and you can see that all the data is here. Now, interestingly, now that the data is here, we have a direct link between Kafka and Druid. As data is coming in, automatically it's getting pushed to Apache Druid. Now let's validate that hypothesis and see if it is working as expected or not. So we have 10 records before. Let's send additional 10 records and see what that look like. If you refresh this and run again, you see we have 20 more records here, and these are the additional records, and you can see the aggregation is on the fly, so we don't necessarily have to write the total sales data in here. All the aggregations are already in place. You can keep putting more and more aggregations into the picture. And if you look at the data source again, we have two segments now, like I mentioned earlier. So this is the first segment, this is the second segment. If you look at the records, this is additional 10 records, and the previous one was also 10 records, if you can still recall, 10 records here, which is good. So that means the data that is coming in in real time per segment is going to be classified into separate segments. So if you have, let's say, 1,000 records coming in every minute, it's going to be batched in as the data is coming in into the batch. Okay, and that's what makes sense. So if any of the segments is corrupted, you can easily just rebuild that particular segment and rebuild it, and you should be fine. Okay then, with that said, let's write some queries here. So let's say for some reason we want to get the total sales. We want to get the total sales and average price by the device. Of course, we need to group by the device. Okay, so we have the total sales already. If you don't want to use the total sales, you can use the price and the quantity anyhow you want it. But I'll just say select the device, the sum of total sales, and the average of total sales. That's fine. From where? From what's the e-commerce data? E-commerce data. Then we group by the device ID. That's device. Yeah, device is fine. If I run this, I see something like this. I'll just call this total sales, and then average sales. Okay. Yeah, that's going to be an error. So this is what it looks like, and this is the total sales, and this is the average sales. Yeah, it only makes sense because as the data is coming in, we're doing the aggregation in real time. So yeah, and yeah, so that's taken care of. I can leave that in here. I'll put this in the query window so you can just copy paste it in there. So I have a couple other ones, so like the distinct users and events by country. So we can have the select country, we have the approximate count distinct, which are the more like the window functions that you usually have in something like SSMS SQL server. We have the unique users, and then the count of star as event count from e-commerce data, and then we group by the country. Yeah, so this is what it looks like. Each of the country is a distinct count, and this is the number of events count. So you can also sort this in descending order. So right now we don't have duplicate records in here, but if I send in, let's say 100, things should start getting more and more interesting now. You can see we now have more records coming in for individual records that are here, and the same thing happened with this guy. If I comment this out and run this, you can see that the data is increasing, and if you look at the segment that we should have two segments right now, even though they're separate, but you can see additional records is 110 records here, but we have two segments for the data in there. Good. So yeah, we can have as much as possible. I think, let me check my notes. I have yeah, I have two more, so let me just pull those in. So let's say we want to check the total quantity and total price per product. Yeah, we have the select product ID, the sum of total quantity. Is it? That's quantity. That's total quantity sold. We have the sum of price, is it, as total price from e-commerce data grouped by product ID. And this is what it looks like. So each of the product ID has the total price of this. You can also check the count star as count of record. So that will be number of products sold. Yeah, so it's still one record. So the product ID is the same, but it looks like the sales are no more than one. So yeah, and that's simply because we have a huge gap between the product. We have 100 product, I believe. Yeah, product ID of 32. So this is going to be random value. Okay, but if you have like a random choice between something like this, so you should be fine. But I'll just leave it at that. Okay, I believe that's understood. Yeah, so the final thing is the time aggregations, which is additional feature that you get to benefit by using Apache Druid. So you have the time aggregations by the minute. So let's say we want to aggregate the data by the minutes they come in. Okay, so we have the select the flow of the data, which is the time that the data come in into minutes. This is going to be called data minutes, the time here. And then we have the count of star, which is the event count. We have the sum of the price. So we get the data by the minute, the event count, and the price of the data. We did the total sales by minute. So we have the total sales. So this is going to be from e-commerce data, where the time is greater than or equals to current timestamp minus interval of 1 day. Let me just group by the flow of time to minute. Yeah, that should be fine. Any errors? Yeah, that's fine. So you can see by the minute. So the data that came in by 7:49 is $3,000 or pound, whatever. By 8 o'clock it's 2,500. But by 8:06 it's 23,000 because it's 100 records. This is the number of records. So if I send in additional records now, so let's say I'm sending 50 records this time around. Yeah, if I check this out again, you can see I just have 50 records here and I have 14,000 records. So the aggregation is being performed in real time, and this can be easily exported to something like Elasticsearch or Superset. So in our case, we've just handled the e-commerce store, the Kafka K-Raft. Apache Druid is taken care of now. So the last bit is Apache Superset. So the video is getting longer, but if you want me to do the part of Apache Superset, so let me know in the comment section and I'm going to pick that up. In the meantime, if you've taken the time to get to this video up onto the end, or you've watched it to the end and you've not subscribed to the channel, please click the subscribe button. Don't forget to turn on the notification bell, like comment and share this video. I love to hear feedback across board. So let me see what you're able to do with this Apache Druid and Apache Kafka in KRaft mode. Don't forget, you can tag me on all social media platforms. I would like to see what project you're able to do with Apache Kafka and Apache Druid, and even Superset, and how you're able to connect with them. A lot of people are already doing great, doing separate projects, improving the existing architectures, and even replicating the same to be able to be able to demonstrate that they will follow along. So yeah, I would really love to see some of those feedback. So don't forget to tag me when you post them on your LinkedIn, your Facebook, your Twitter, or anywhere else, or even TikTok. I'll be more than happy to see them. So thank you very much for watching this video. I'll see you in the next one. Cheers.